How are we doing, everyone? Today, we're going to talk about simplifying perfect squares that are not actual perfect squares. So I have three rules of thumb here that we're going to type into your document as well. But this is how we want to approach simplifying perfect squares. First, we want to find the largest perfect square that is a factor of the actual term we're trying to simplify. Okay. Once we find that largest perfect square that's a factor, we're going to simplify that perfect square. Okay. I'll go into more detail with that in a minute. And then finally, once we've simplified that perfect square and pulled it out of the radical, we are going to then leave all the non-perfect squares underneath the radical. So this is the process that we are going to follow, and it makes it a lot simpler than there's some where they go with prime factorization. We're going to teach you to find and look for the largest perfect square. Okay? So, for example, when we're talking about the perfect squares, now I only listed our perfect squares up here in purple. They're all the way up to 12 squared, 144. I'm not going to include 1 because we know that if we just multiply or divide by 1, it doesn't change the number. So we want to look at from 4 all the way up and using our perfect squares. Right now we're going up to 12, but we could continue this infinitely if we wanted to. Okay. So very basically, we are looking for these numbers up here. These are the factors that we're looking for. In the slide I gave you prior, I gave you a little Star Wars joke in there, just like Obi-Wan saying, these are the droids you're looking for. So these are the factors you want to find, okay? So if I take like the square root of 49, I'm looking for myself to say, hey, is there a perfect square that's a factor of 49? Now, this is a unique one because, in fact, 49 is right up here. So actually, that is a perfect square in and of itself. So in reality, the square root of 49 is exactly the opposite of what is squared to make 49, which in fact is 7. And that would be it, okay? So what we've done is we've pulled that 7 out of the radical because the square root of 49 is 7, okay? Now let's go a little bit more complex. We look at the square root of 50. Well, 50 is not one of those numbers that's up here, okay? So I want to find the largest perfect square that's a factor of 50. And here's the progression you should probably go through. You should probably start looking at some of these numbers and saying, well, there's no way 144 is going to be a factor of 50. It's already larger than 50. So what you should do is start canceling out numbers that cannot be factors of 50. Even if you went to 49, no whole number times 49 is going to give you 50. Same thing with 36. Nothing times 36 is 50. So right now you've limited your choices to either 4, 9, 16, and 25 if there is a perfect square in here. Well, we know a factor, the largest perfect square is a factor of 50 is actually 25. So here's how we do this. We're going to split this radical into those factors. So we're going to split it into the square root of 25, and then 25 times what gives me 50. Now you're just dividing 25 times 2, okay? What I like to do then is circle my perfect square, all right? So here's my perfect square that's 25, and that's the largest perfect square. It's a factor of 50. So now I ask myself, what is just the square root of 25? And I'm going to pull that out of the radical. The square root of 25 is 5. And now, because unlike square root of 49, where there is just a perfect square, I actually have something left here under the radical, this 2. Well, there is no 2 that I see up here or a number that's a factor of 2 that is a perfect square. And I know what you're thinking. Well, 2 squared is 4, but that's not the square root of 2. Okay, those are two different things. If this was a 4, I would say yes, you could pull out another 2, but that's not there. Okay, so that is what's going to stay underneath our radical, and we just leave it as 5 root 2. Okay, and that's your final solution. Now, very simply, root 2 is a number. Root 2 is like saying we have an x, a y, or whatever, any variable. Root 2 actually ends up being it's not a rational number, okay, because it's like pi. You can't write it as a fraction. It actually ends up being close to about 1.41, etc. It repeats infinitely. So this is really 5 times the square root of 2. Or similarly to when we said 5 times x is like saying 5x. Okay? So that's all we're doing here. As soon as we get down to either a prime number or a number that does not have a perfect square, then we're done. Okay? So now I'm going to look at 72. Okay? 72, we want to take the largest perfect square, okay? So as I look at my terms up here, I'm going to start eliminating choices. It's not 144, too large, 121 is too large, 100 is too large, 81 is too large, 64 is less, but again, too large. There's nothing times, no whole number times 64 that gives me 72. 49, I could try 49 times 2, but that gives me 78 and not 72. Or excuse me, that gives me 98 and not 72. I apologize. So then I start looking, I'm between 4, 9, 16, 25, and 36. Okay. Well, I know it's not going to be a 25 because this does not end in a 0 or 5. That's just knowing my factors of 25. Okay. So it could be 4, 9, 16, or 36. I want the largest perfect square. So I could actually try a little trial and error here and start dividing by some of these. So my largest number is 36. We'll try that. We'll see if 36 divides into 72, which in fact it does. 36 times what is 72? It's 36 times 2. And again, we have that largest perfect square. The square root of 36, I'm going to pull out the square root of 36, which is 6. And then what's left underneath the radical is this 2. Just like we had that 5 root 2, now we have a 6 root 2. Okay. Finally, the square root of 360. Well, if you know anything about your multiplication, you could at least split this and try it a different way by saying, all right, well, I don't know the perfect square that's in here. A lot of you probably figured it out, but I know it ends in a 0, so I know it's divisible by 10. So what times 10 is 360? Again, we have 36 again. That's our perfect square that we want, okay? So then I'm going to take the square root of 36, which again ends up being 6. And then what's left underneath the radical is this root 10. Now, root 10 always throws my students for a loop because they say, well, it's an even number that's not 2. A lot of times we like saying, hey, if we get a prime number like 2, 3, 5 underneath a radical, we're in good shape, okay? Because there is nothing further you can take if it's a prime number, because we know the only factors of them are the number itself and 1. 10 is composite, but the only other factors of 10 other than 10 and 1 are 5 and 2. So you have to ask yourself, are those perfect squares? Are they any of these numbers that are up here? The answer is no. So 10 is one of those unique even numbers that's composite, but doesn't have a perfect square. You would be done here. Okay? So I hope that was informative. If you have any questions, make sure you contact your teachers, and we will be happy to help you guys out.